Greetings, Math 10 students. In this video, we're going to take a look at section 7.2 on the basics of polynomials and how polynomials work. You won't see a Hawks assignment from this section, but you will have a homework post on this asking you to evaluate polynomials. If you read through the section, it has a lot of discussion on classifying polynomials and various other ways to think about polynomials. I'm not worried too much about some of those details, but I do want to make sure that you understand that these formulas can be evaluated just like the other formulas that we've worked with in this class, but they're a little bit more involved because they involve exponents. So a polynomial is going to be pretty much any formula that you see that involves positive whole number exponents. Exponents should never be negative or variables or anything funny like that in polynomials. And basically one way to think about a polynomial is that it's a formula that's made up of terms that look kind of like this. Each term is going to be a chunk that looks like this. They'll all have an exponent. So the 2 here is an exponent. And if you take a look at the videos from last week on exponents, this will be familiar. So that's my exponent. They'll also typically have a base. The base for polynomials will almost always be a variable. So the x here is my base. The exponents, as I said, are always going to be positive whole numbers. And then they'll typically also have a coefficient. Sometimes your coefficient is 1, in which case you just typically don't write it. So you'll typically also have a coefficient. And again, I mentioned this is something that came up in last week's videos. So some examples of polynomials. Here are some typical examples of what these things could look like. Here's a perfectly good one. 9x to the third power minus 8x to the second power plus 2x. Another way that you can say a third power is cubed. If you want to say that's 9x cubed, you can. Another way to say x to the second power is squared. You could say that's negative 8x squared or minus 8x squared. Please, please, please do not say that this is 9x3. That sounds kind of corny, and your math professors in your later on classes are going to look at you kind of funny. So sound like you know what you're talking about and say 9x to the third power. You both sound smart and you are smart. So good to always try to say those the proper way. The terms here, I've already kind of pointed out, are the 9x to the third power. That's a term. Minus 8x to the second power. That's another term. And then the plus 2x. So that's a perfectly good polynomial. Has 3 terms. Like I said, the textbook is going to talk about naming, different naming conventions for polynomials based on how many terms they have. They'll talk about the degree of a polynomial, which is just the largest exponent you see. Don't worry too much about that stuff. It's good to read through, but don't stress it too much. Another example here, x to the second power minus 9. Perfectly good example. Now you'll notice that some of these terms don't quite follow the format that I have of coefficient base exponent. For instance, in this first one, the 2x doesn't have an exponent. That's okay. If there's no exponent with a variable, you can just put a little 1 up there. Secretly, it's 1. We don't write the 1 because x to the first power literally means, well, take your base of x and write it out 1 time. So x to the first power literally means, hey, here's my 1x, and there it is. Same thing with the first term in the second polynomial. There's no coefficient there. Well, that's okay. We've seen this trick before. If you don't see a number in front of the variable, you can always put a 1 there. So that's 1x, because 1 times anything is the same thing. The weird one, though, is this negative 9. There's no x at all. That's what's called a constant term. You can technically think of it as x to the 0 power, but it's better to just think of it as its own special beast. It is technically possible to think about it as x to the 0 power, but to summarize, variable, if it doesn't have an exponent, just make it a 1. You can actually put a little 1 up there, especially when we're multiplying exponents. That can be helpful. And if a term doesn't have a variable at all, if there's no x or y, if it's just a number, that's called a constant term. It's a little bit different, but it essentially is going to act just like any other term. Alright, so in this section you're going to be asked to evaluate polynomials. Let's take a look at how that works. Typical question from this that you'll have to post on would look like this. Evaluate the given polynomial. And here they give you a polynomial. Ooh, that's funny. What's that little p with parentheses in front? We'll talk about that. And then this is what the question's going to look like. Say what? Don't panic. This is a fancy type of notation called functional notation. Essentially all they're doing is giving your polynomial a name. This p with parentheses and then an x in there isn't talking about multiplication or anything like that, even though that's what it kind of looks like. It's just giving a name to this polynomial. The p with the parentheses x is read p of x. Don't worry too much about that, but it's just the name for that formula. They're just giving it a name in case you have to use it a lot. It's like how we say the compound interest formula instead of every single time having to say out all the pieces of that formula. And then this second part here, p with the parentheses 2, you'd read p of 2, but don't worry too much about that. Essentially it's just saying, hey, we're going to use 2 as the input for x. So some fancy notation, just because especially later on when you get to a statistics class you're going to be using certain formulas over and over again. It's nice to be able to give them names, and then this special fancy notation is just to let you know that you're taking 2 as your input. So what does that mean? Let's break it down step by step. First thing you're going to do, since they're giving me 2 as an input, is I'm going to replace each x with the given input in parentheses. So the big difference between this and some of the earlier formulas that we've seen is you've got more than one x here, and each one gets replaced with 2. You can kind of think about it as I'm going through this formula and I'm erasing all of the x's. I just take my eraser out and replace each of the x's, erase it and replace it with the number 2 in parentheses. The parentheses are there to help you remember what operations are going on, and they're also there in case you have a negative to help you keep track of those negative signs. So here's what that's going to look like. The first x became a 2 in parentheses, but the 3 coefficient comes down and the exponent comes down. Here's where understanding that breakdown of each term can be helpful. It just reminds you that each of these terms should have those 3 pieces, and I'm just replacing the base of x with my input. So the negative 5 coefficient comes down and is again negative 5. My x gets replaced with 2 in parentheses, but I bring the exponent of 3 down. And then last but not least, 2 as my coefficient comes down, I bring down the base of x, I turn it into a 2 in parentheses, and there's no exponent there. I don't have to put the 1. I could just leave that. So I'm just replacing each of the variables x with the number 2 in parentheses. Next, I'm going to just evaluate this using our old friend order of operations. Please excuse my dear Aunt Sally or PEMDAS or however you learn that. The p for parentheses doesn't really come into play here, but you will always have to do those exponents first. So let's take a look at that. My exponents are the 2 to the 4th power. That's going to happen before I can multiply 3 times 2. So don't just hit 3 times 2 here, and be careful because different calculators are different with order of operations. Some of them are very, in fact, all calculators are very dumb. They don't know what you mean. They just listen to what you type into them. But be very careful. I encourage you to do the exponent first in your calculator, and I would encourage you to write it that way in your homework post. This is a perfect way to write it, is to do this exponent first. So 2 to the 4th power is 16. Careful, it's not 2 times 4, it's 2 to the 4th power. So you could, in your calculator, hit 2, your exponent button, which probably is something like this, x with a little y, and then 4, and then hit your equal sign, and that's going to be 16. Or you can actually just expand that, 2 times 2 times 2 times 2, right? That's what 2 to the 4th power means. Either way, it should come out to 16, and just bring the coefficient of 3 down. Same thing's going to happen for my second term. I'm going to evaluate the exponent, 2 to the 3rd power, which is 8, and I'm just bringing the negative 5 coefficient down. And this is, again, this is the best way to write this in the homework post. And then 2 times 2, I know I could do that, but I'm going to just bring it down. Bring it down. We'll multiply later. So exponents, check. Done. Let's move on to the next step, which is multiply and divide. Well, there's never going to be any division, so we could just multiply here. 3 times 16 is 48. Negative 5 times 8 is negative 40. Be careful with sign rules here, because if that 8 had been negative, I'd end up with a positive. So just make sure that you're careful with your sign rules in this step. And now I'll do the 2 times 2 to get a 4. And then last step is add and subtract going straight across. And I got 12 when I did that. So 48 minus 40 is 8, and 8 plus 4 is 12. So my final answer would be 12 here. When you're evaluating polynomials, you expect to get just a nice solid number as your answer. So to summarize, polynomials are going to be formulas that are made up of terms. Each of those terms has a coefficient, a base, which is usually a variable, and an exponent. Sometimes your coefficient and your exponent are 1, and sometimes you get a constant term, which just doesn't have a variable. The terms always have plus or minus signs between them. To evaluate an exponent, you'll often, in the textbook, they'll write it in function notation. You can ignore this p with the x thing. That's just the name of the polynomial. You're just going to replace the x with whatever input they give you, and then use order of operations to evaluate it. Do your exponents first, write the answer on the next line, multiply, write the answer on the next line, and then add and subtract across.